everybody. In this video, we're going to talk about how to add and subtract fractions with length models. So if we wanted to add the fractions 2/7 plus 3/7, the first step is to split up our number line so that the distance between 0 and 1 has 7 little units of 1/7 each. So the way I like to do this when I'm splitting up the number line is I like doing things that are either halves or thirds. Those are really easy for me to kind of visualize and space out. So since 7 cannot equally be divided by 2 or 3, I'm just going to mark off a little mark that I think looks like a seventh to me. And then I'm going to split up the remaining space where I should have 6 spaces in half because 6 can be split in half. And then these 2 spaces need to be 3 spaces each. So I'll split those into thirds. So I wanted to kind of verbalize my process for splitting up the number line because I know it can kind of be difficult and it can take a little while to get your spacing correct. Also, another thing to note is that there's 6 tick marks to make 7 spaces. So if you look at these marks that I have here, there's 6 of them when my goal was to make 7 spaces. Also, notice that I didn't do this perfectly. Like, for example, I should probably adjust this and move it over a little bit. And even with that adjustment, this distance that I just kind of eyeballed is not necessarily the same distance as all the other ones, but it's close enough that it should still work. So now that I have my number line split up, I'm going to find the number 2/7, which is this point right here, because that's a distance of 2/7 away from 0. And then I'm going to add another distance of 3/7. So this 3/7 is being measured from the end point of the 2/7 mark because I'm adding this distance onto this distance that I already had here. And that gets me to the point right here that is my answer. And that point is 5/7 of a unit away from 0. And so my answer is 5/7. If you're subtracting fractions, it's basically the same process, except instead of adding the distance on, you're going to take the distance away. So I'll start off by splitting up the distance between 0 and 1 into eighths, which is really easy because 8 can be divided in half. And then each of those can be divided in half to form fourths. And then I can split each of those in half to make my eighths. So 8 is a really easy number to divide. And once I have my marks written on my number line, then I can find the 0.58. So I have 1, 2, 3, 4, 5. That's this point right here. And then I want to subtract 2/8. So I'm going to go backwards 2 units. And that gives me my answer right here, which is 3/8. So you can just explain it to your students as going backwards because you're taking away that distance. Later, you'll introduce, well, it depends on what grade you teach, but if you teach older grades like sixth grade, this will be very relevant to when they start using negatives. So it is helpful to teach them this concept early when they're only dealing with positive numbers because it will build a good foundation for later when they learn about adding and subtracting negatives. So let's talk about how you could use a length model to represent adding fractions with uncommon denominators. So remember, fraction strips are one way to represent fractions with a length model. So if I had 1/5 plus 2/3, the way that I would calculate this is by making it so that we have common denominators. So you could use the least common multiple method, or you could just multiply the two denominators in this case, and both of them would give you the common denominator of 15. So the common denominator I'm shooting for is 15. So how do we visualize the process of changing 1/5 into 15ths when you're dealing with a length model? Well, it's basically the same as all of the other ones. We're going to multiply the top and the bottom, and this 1/5 is going to be split up into 3 pieces. Now, in a area model, you would also split up all the empty space into 3 pieces. Um, all of the empty fifths in the whole. But with a fraction strip model, you're just going to do it for the fraction strips that you have here. And then for the 1/3, we'll go ahead and split those up as well. So I'm going to multiply by 5, and I would have 1, 2, 3, 4, 5, 1, and then I'll split this in half, split this in half, split this in half. And so that tells me that I have 10/15, and I forgot to write in my 3/15 here. Now, we can see in this fraction strip model that we still have some empty space, and we don't actually even know what that empty space is. Um, but if we add the fractions together, we could find out, because 3/15 plus 10/15 is 13/15. And that tells us that this empty space must be 2/15. And if we look at the spacing of that, that looks accurate, that you could fit 2/15 in there. If you wanted to use a number line model, you're kind of going to be using two different tick mark systems. So if I wanted to do 5/12 minus 1/9, I would say, okay, well, let's first show the 5/12 mark. So we're going to have the distance between 0 and 1 split in half, and then I'll split that in half and this in half. And then each one of those needs to be split up into thirds. So it looks kind of like this. And then for the ninths, I'm going to split this up into thirds, and then split each of those up into thirds. So it's going to look kind of like this-ish. By the way, this is much easier to do if you have like a automatic number line generator. You can find applets for that online. Much easier to do because you want these lines to be matching up in the right spots. So I kind of knew that like 4/12 and 1/3 or 3/9 should match up because they're both equal to a third, but you may not want to be doing all those calculations in your head. So if you use a number line generator online, it will get the spacing right, and then you don't have to worry about trying to do that in your head. So we have all of our number line spacing here. And if I go to 5/12, I'm going to go 1, 2, 3, 4, 5. That's this point right here. And I want to subtract 1/9. So I know that I'm going to end up about right here, because if I subtract 1/9 and I go back to here, I know I'm going to end up there, but that doesn't even have a tick mark on it. Um, I know that's about where I should end up, but I don't know what that point is. And so this is where you create common denominators. And you say, okay, well, what's the least common multiple of 12 and 9? Well, if I count by 12s, I have 12, 24, 36, 40, 8. Sorry, that took me a minute, and so on. And then if I count by 9s, I have 9, 18, 27, 36, and there's our least common multiple. So I'm going to convert these to 36. And the way I'll do that is by multiplying 12 by 3, which gives me 15/36. And what I would do to show that visually is that I'm going to split this distance up like this. Yeah, like that. So each one of these little spaces is getting cut up into 3 equal sized pieces. And then I'm going to do the same thing with the ninths. And to change ninths to 36, I need to multiply by 4, which means that I'm going to split up each of the distances between these blue tick marks into fourths, which looks kind of like this. Whoops. Yeah, like that. And notice that all of these tick marks are lining up. Again, this is much easier to do if you have a number line that is made online that is well spaced instead of you trying to space it. And when I multiply the numerator of my 1/9 fraction, that tells me that I will be subtracting 4/36. And notice that when I subtract 4/36, I end up right at that point where I estimated I would be. And so now I just need to figure out what that point is. So I'm going to say, okay, this is my answer. How far is it away from 0? Well, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 36 away from 0. And that's why 15 minus 4/36 gives you 11/36. And so that's how you can show uncommon denominators on a number line. So if you have any questions, let me know, and I hope you have a great day.